In my last video, I showed you how to implement Redux patterns in Angular using Ngrx store. If you're brand new to Redux, I recommend checking out that video first if you haven't already. If you're an Angular Firebase Pro member, I'd like to take a second to say thank you for supporting this project and let you know that we're using your investment to support other open source projects such as Ngrx. I pledged $100 per month and we'll do the same for other exceptional Angular projects and content creators. Getting back to this episode, we're going to build an Ngrx Angular app that uses Firebase on the back end. We'll be able to retrieve as well as update posts on the Firebase real-time database. When working with Firebase, we have to worry about the side effects that come with working with a third-party API. Ngrx has a package called effects that serves just this purpose. We can install it using npm. At this point, you should have Angular Fire 2 for Firebase installed. You can find instructions for that on the official repo. Now let's look at why we need to use effects in the first place. Consider the following example of a pure function. It's considered pure because it only affects data within its own scope. It would be considered impure if we defined a variable outside of that function and then used it inside the function scope. What often happens in the real world is we have an impure function that will do an operation on the database, causing a chain of different side effects in the application. The goal of Ngrx effects is to isolate functions like this to make them behave more or less like a pure function. Let's start coding this up in Angular in the app module. We're going to need the Angular Fire database, as well as the effects module, store, and store dev tools. Then we're going to create our own post effects and post reducer in the upcoming steps. Post effects behave just like an Angular service, so when we import them, we add them to an array in the effects module. Then the reducer is added to the store module. Now, before going any further, I want to show you how I have this app organized. I have a folder for actions, effects, models, and reducers. You'll most likely want a similar organization to this for each feature in your app. Now, let's get started building the post model. This will just be a simple TypeScript interface that defines the post itself. The push key will be the actual Firebase push key, and then we'll have a loading state that's a Boolean, then text, votes, and an optional error field. Now we can start building the post actions. We'll start by importing the action interface from Ngrx, and also the post model that we just created. To create an action, we'll first export a constant with the action name. Then we create a class that will handle the data payload for that action. In order to get a post from Firebase, we need to first supply it with a push key string, which we can do by supplying it in the constructor for this action. When we make a GET request for a post, it's asynchronous. We don't know if it's successful right away. So we'll create another action called getPostSuccess that will fire once the post is actually successfully retrieved. For the vote actions, which are conducted with a Firebase database update, we'll do a success and a fail action to handle those two possible states. When we successfully retrieve a post, we can send that as the payload to update the data store. Then we'll follow the same basic process for all the other actions. This will make a little more sense when we get to the effects and actually start sending data through these actions. The final step is to export all these classes as a single type so we can strong type them when we get to the effects. But before the effects, we'll build the reducer function. In the reducer function, we will import the post actions we just created, as well as the post model we created earlier. Then we'll set the post actions as a single action type. In the post reducer, we pass the state and the action as arguments. Then to copy the old state to the new state, we're going to use a new JavaScript syntax called spread. First, we create an empty object, and then we put other objects inside of it with 3 dots in front of them, and this will compose a new object from left to right. When we first trigger the getPost action, we'll set the loading state to true. When the post returns successfully, we can add the action payload to the object and also flip the loading state to false. Then we'll follow the same basic logic for the vote actions, and you might notice how concise and readable our code is with the spread syntax. However, keep in mind it's just a proposal for ES7 and it's not a fully standardized feature in JavaScript as of the making of this video. Now we can finally start building our post effects. Effects work just like an Angular service, so we'll use the injectable decorator, and then we'll import effects, actions, as well as the Angular Fire database, and then a few RxJS operators as well, which you'll see in use here in a second. And lastly, we'll import our post actions. The first step is to add the actions as well as the Angular Fire database in the constructor. Then you create an effect by first using the effect decorator. Then you strong type its value as an observable action. Then you call actions of type, and the type being the action that you want to perform. In this case, it'll be our get post action. In this case, we need to first map the payload down to something that we can use. Since we strong type all our actions, we can just map it down to the action type for get post. In this case, the payload we're sending it is a Firebase push key that we can use to retrieve the post from the database. In this example, I'm using an Ngrx.js delay of 2 seconds just to show the spinner in the UI. That's not necessary in real life. So now we can use merge map to take that payload of the Firebase push key to send the actual GET request to Firebase. We call db object payload, and then we map that down to the post that it returns, and then we can actually update the state in the data store. And we can do that by just returning the post action's get post success. When we trigger this action in the front end, it's going to look something like this. We get a 2-second delay, and then the post data is updated in the data store, reflecting in the UI. Now let's build another effect to handle the voting action. It's the same basic process to start, but this time it'll be a type of vote update. Then we'll map it down to the payload just like we did with the last effect. But the difference is when you do a Firebase update, it's not actually an observable, rather it's a promise. But we can treat it like an observable by putting it inside the of operator. Then we can simply make the update call to Firebase like we would normally by calling db object with the push key, and then we'll update the votes to the new value specified in the payload. Then we can map the observable to the vote success action, and if there's an error, we can catch it and trigger the post action's vote fail, which will set the optional error property on the data store to this error message. Now let's actually put these effects to use in the app component. We import Ngrx store as well as our post actions and post model. Then the app state interface will just be defined as the post. And just like we did in the last video, we'll set the post as an observable and we'll inject the store in the constructor. Now all we have to do is create a couple event handlers that will trigger these actions. To get a post from Firebase, I'm just going to hard code a push key that already exists in the database. Then to update the votes, I'm going to pass the existing post object along with the new value we want to set the votes at. Then we can dispatch the action and pass it the post and the new value for the votes. In the app component HTML, we just need to unwrap the post observable, and then we can bind everything to buttons that we need to trigger the get post action as well as the vote update action. And then we also display a loading spinner conditionally if the post is loading. To distinguish an upvote from a downvote, we just pass it the number 1 or the number -1 if it's a downvote. In a real app, you'd probably want to have some way to validate that a vote belongs to a user, but in this case, I just want to show you how to actually make the update in Firebase. You can see when we click the upvote or downvote button, Firebase is being updated over here on the right, and we're observing the actual data in the data store, so it's completely decoupled from Firebase. If you installed Redux DevTools in the last video, you'll be able to get a nice tree presentation of the state as it changes. So first we have a blank state, then it goes to the loading state, and then the post data is loaded, and each time we vote, we get a new state tree. As your app grows more complex, this can be extremely helpful for debugging. That's it for Ngrx effects with Firebase. If this video helped you, please like and subscribe. And if you want to support the channel, consider becoming a pro subscriber at angularfirebase.com. You'll get a free copy of my book, as well as one-on-one project consulting. Thanks for watching, and I'll see you soon.